Hi everybody, this is the fourth video on the binomial theorem, and so far we've learned about choose numbers and we've learned a little bit about how to expand a binomial. I want to make note of something. The binomial theorem is actually written right here, and I'm going to highlight this in blue. And I mean, it looks very complicated, but you got to notice a couple things. First of all, we have these numbers, these choose numbers in front. Those are the numbers that we take out of Pascal's triangle. Okay, those are what we call the binomial coefficients. And then if you kind of look at the individual variables, right? A descends, it starts at the highest power, which is n, and then it goes down by 1 to n minus 1, and then n minus 2, and then finally goes down to the first power, and then it disappears at the end. And the b's, if you look at the b's, they do the exact opposite, right? B, you can't even see it because it's b to the 0, and then b to the first, and then b to the second, b to the third, so on and so forth. And finally, you get up to the second highest power, and then whatever the power is, so it's the 8th or the 9th or the 5th. So the A's descend and the B's ascend. That's mathematically how you write it. I mean, there's not a better way to write it like that. And you notice in the middle there, they have 3 dots because we don't know how long, it depends on what n is, right? If n is 5, you're going to have 6 terms. If n is 9, you're actually going to have a 10-term polynomial. So we don't know. So we put those 3 dots, those little ellipses in the middle of the problem. All right, I want to point that out because we're going to skip down here. We've done a whole bunch of problems. We're actually on the 3rd page of this PDF, and we're going to expand a complex number, which is just like a binomial, right? Complex numbers have an imaginary part and a real part. So all you have to remember, and you got to keep in mind, what is I? I is the square root of -1. So I squared is -1. So we'll need to have that fact in mind kind of towards the end of the problem. Okay, so first things first, when you're expanding a binomial, you look at Pascal's triangle, which I wrote on the previous page, and it's the 4th power. So we're going to use actually the 5th row down, the one that has a 4 as the second number in. So the coefficients we need are 1, 4, 6, 4, 1. And again, I'll give myself a lot of room here, right? I'll take the whole width of the page and trying to do this, 1, 4, 6, 4, 1. And I'll try to color code this for you as best I can. I'm going to take the first term, which is 2i, and I'm going to descend it, right? I'm going to take 2i to the 4th power, and then 2i to the 3rd power, 2i squared, 2i to the 1st, and then it disappears at the end because it would be 2i to the 0. And then my next term, let's do it in green for the Eagles. How about that, since they just had the NFL draft? We're going to take -3 and ascend it. We're going to make the powers go up. But the first term, we start at 0, so it doesn't appear. And then it's -3 to the 1st, and then -3 to the 2nd, and then -3 to the 3rd, and finally -3 to the 4th. And in between, just a bunch of plus signs. And I think you see why I wanted to use the width of the page, because it's just a lot, right? After this, we do algebra. By that, I mean 2 to the 4th is 16, I to the 4th, right? And then here we got 4 times 2 cubed. 2 cubed is 8, times 4 is 32. 32 times 3 is 96 with a negative. I didn't note it. I'll put it right there for now. And then I got I to the 3rd. All right, let's get the coefficient. I got 2 squared, that's 4. 3 squared is 9. I got 4, I got 9, that's 36. And I got 36 times 6 is, man, I think it's 216. And then I got I is still to the 2nd power. And that -3 squared, that negative goes away, it becomes a plus. All right, next term here. Maybe I should have worked these out ahead of time. These numbers are getting kind of big. I got 3 cubed, that's 27. And 4 times 2 is 8. 27 times 8 is also 216 with an I. Actually, I hate to do this. I got to check this on the calculator. I think it is 27 times 8. Yeah, it is 216. And then finally at the end, I got negative 3 to the 4th. 3 to the 4th is 81. And again, a negative to the 4th power is positive. But that makes me think, the term just before that, negative 3 cubed, that's a negative. So I've got to have a negative in here as well. Okay. Finally, I'm not quite done. For one thing, I have all these little double negatives. Let me circle them there. I got those double negatives in there I didn't take care of. And the other thing is I got these i's. And we got to remember I squared is negative 1. So where's that? I squared here. That's negative 1. So this is going to become a minus 216 in the middle. I to the 4th, well, what is I to the 4th? It's just I squared times I squared. So that's negative 1 times negative 1, which is 1. I think somewhere in Algebra 2 you learned about the powers of I. They have this pattern, but I to the 4th is just 1. So this is just 16. And then we got I to the 3rd. Well, that's just I squared times I. So that's negative 1 times I, or negative I. So I cubed is negative I. But that negative gets together with the negative 96 and gives me a plus. So I get a 96 and I still have I hanging around. Here I get a plus minus. That's a minus 216I. And I get a plus 81. A lot of fun, isn't it? Yeah. Okay, finally, get your like terms together. So I think I'm going to get my real numbers together. So 16, negative 216, and positive 81. So 16 minus 216, that's a negative 200. And a negative 200 plus an 81 would give me negative 119, negative 119. Now I got to get my imaginary terms together. So I got 96 minus 216. And if I take 96 minus 216, I get negative 120. Oops, my bad. Negative 120I. So there we go, negative 119 minus 120I. You'll find that when you take a complex number, raise it to any power, you just get a complex number again. You don't, with binomials, with a letter, with an X or an A or a B, a 4th power would give you 5 terms, but because of those powers of I, you're just going to end up with a binomial or just another complex number. Real quick, number 12, I'll kind of rip through that one. It'll be the same type steps. It might be easier because I don't have those coefficients of 2 and 3 there. I go to the 6th row of Pascal's triangle and I write out those coefficients, which are 1, 5, 10, 10, 5, 1. And again, space them out. You're going to need space. We're going to take the first term and descend it. Right? So we're going to have I to the 5th, I to the 4th, I cubed, I squared, and I. And we're going to take negative 4 and we're going to ascend it. So negative 4 to the 0, negative 4 to the 1st, negative 4 squared, negative 4 cubed, negative 4 to the 4th, and then negative 4 to the 5th power. One of the problems I think you're seeing with powers is the numbers can get out of hand pretty quick. But that's why we have the TI-84, right? Or whatever calculator you like. In fact, you're on a computer now, you can just use Desmos or just the calculator feature of your laptop. Okay, again, real quick, powers of I, right? and I'll write this above. I squared is -1. I cubed gives you a negative I. I to the fourth is an I squared, and I squared, which is 1. And then, I to the fifth, you're right back at I, and that kind of pattern continues. These are just the powers of I. I equals I, and then it goes -1, negative I, and then 1 again, and then you're back to I. Okay, so I to the fifth, that just gives me I. 5 times -4, that's -20. So I got a -20. There I am with double signs again. You can take care of that right now. I'm just going to leave it there as a double sign for now. Now I got plus. I got -4 squared. That's 16 times 10. I got 160. I got I to the third, which is a negative I. Yeah, here's where the numbers get big. 4 cubed, that's 64 times 10. That's 640 with a negative. So it's -640, but I squared is -1. Next term, I got 4 to the fourth, which is 256. And I got 256 times 5, which is 1,280. Boy, this is fun, huh? And then finally, 4 to the fifth, I think is 1024. I'm just checking. It is. It's 1024. And a negative to the fifth power is still negative. So it's -1024. Okay. So now what do I got to do? I got to add up my i's, and I got to add up my whole numbers here. So first of all, I'm checking for mistakes. I don't really see any. I'm just checking one thing here. I think we're good though. Okay, well, let's do it. All right, what do we want first? Let's get the real numbers. So we got a -20, and I'm doing this on the calculator. Here I got 2 negatives. That's a +640. So I got -20, I got +640. And then finally I got -1024 or -1024. So my real part, I got -404. Now I got to get my imaginaries. Let's pick out a new color just to make things exciting. I got an I there. I got a -160I. I got a +1280. Okay, so I got one I got -160, and I got +1280, and that looks like 1121I. So that's +1121. Oops, 1I. All right. I think that's far enough for this video. We'll probably do one more video to round out this theorem on this video series on the binomial theorem.